In this problem, we are tasked with constructing a function as a function of cost as a function of the radius of a can. The material that the can is made from, the top and bottom of the can is made of material that costs 6 cents per square centimeter, and the side of the can is made of material that costs 4 cents per square centimeter. We are told that the can must have a volume of 500 cubic centimeters. So the volume of a can is 500 centimeters cubed. Okay, well, the volume of a can is pi r squared h. So this is therefore 500. And if I rearrange this, then I can find h as a function of r. So if h is 500 divided by pi r squared. The cost as a function of r, well, let's first work out the area as a function of r. So the area of my can, and I have this sort of schematic of our can here. When it's broken down, you can see the top and the bottom, and then this will be the side as it is rolled out. And so the area is, well, the area of a disk is pi r squared, and I have two of them, top and bottom, so I will have 2 pi r squared plus the area of the side. Well, it makes the shape of a rectangle, so it's length times width. That's 2 pi r times h, so 2 pi r h. And so I should actually erase this. Sorry, I don't have the area as a function of r right now. I just have the area in terms of r and h. But what I'm going to do is I'm going to replace h in my function with what I have up here, 500 over pi r squared. And so I have a is therefore 2 pi r squared plus 2 pi r, and I will replace h with 500 over pi r squared, so that's 500 over pi r squared. I can do some canceling. One of my pi will cancel in the second term, and an or will cancel with one of these ors down here. And so if I tidy up, bring everything together, I have therefore that a as a function of r is 2 pi r squared plus 2 times 500 is 1,000 over r. So that's the area as a function of radius. The cost is going to be each of these terms times the cost of the material for that given part of the can. So this 2 pi r squared represents the area of the top and the bottom, and each of those costs 6 cents per centimeter squared. So the cost now as a function of r is going to be, that's 2 pi r squared times 6 cents. So I'll put in 0.06. Keep my units in dollars. Plus, I have 1,000 over r times the cost of that material is 4 cents. So that is times 0.04. And I have, therefore, that the cost as a function of r is 2 times 6 cents, so that's 12 cents, so that is 0.12 pi r squared plus 1,000 times 0.04 is 40, and so that's 40 over r. And that is what we are asked to do: express the total cost C of the material as a function of the radius r of the cylinder, and there you have it. We are then asked, just in the second part, to graph this function. So this is our function. That is the first part of the question. That is cost as a function of radius. In the second part, we're asked to graph it, and I have done that down here. I have graphed our function, as you can see, 0.12 pi x squared plus 40 over x. I have limited my domain from 0 to 20, and you see this graph right here. It makes what amounts to is almost a parabola, and it has a minimum value right here. This is its minimum value. And so the value of OR is 3.758. So that would be 3.7, rounding to two decimal places, 3.76. And so, sorry, the cost is minimized for OR equals 3.76. So 3.76, and that would be in centimeters. And that is our solution right there. Again, you can see that is our function in the domain 0 to 20. And that is our answer.